So, today is purely a homework review day. Hope you guys get going on chapter 2 and finish it up, and then next week we will get into chapter 3 and maybe even a little bit of chapter 4, try to get a little bit further ahead. So, having said all that, the way this will go is we will turn the time over to you all as students, and it's just kind of up to you if you have some things you want to talk about, questions you have to ask, and I will answer them to the best of my ability. Yes, sir. On number 5, okay. Let's take a look at number 5. Go here to my... Okay, let's see. First, let's go home here. Let's figure out where we're at. Number 5, you say?
Yep.
All right. Remember that my question will be slightly different from your question as far as numbers go, but you get the idea here. Yep. So we have a cop car, which is A, and it passes a sports car B, as shown in the diagram below. The cop car is traveling 43 meters per second. Sports car is traveling at 31 meters per second. Now, we talked about this a little bit on our first day of chapter 2. I can't remember. This is this the only one that has a relativity type problem? I think it is.
I think so.
Yeah. The reason.
No, the one that has like a balloon in the river and
Oh, yeah, there's a big shore.
Okay, so there's one other one.
Oh, is that the big one?
Number 15, you're thinking, is also 13, maybe?
her.
Yeah.
This is the one with all the questions.
So yeah, we did talk about this the first day, and let's go back and take a look at that in our textbook really quick.
I actually got confused
What's that?
on that one. I got confused about the part with the banner, how fasteners, like how, I don't remember this. Like his perspective of how fasteners.
Are we in the same problem, or are you talking about the same problem?
Because
Well-
I put 4 miles per hour, but it's 0. But like if he looks at a tree that's still when he runs by, when he
Okay, so we'll get to that here in just a second, and we'll talk about that. So right here is where we discussed this problem when we did this problem with the plane moving, right? And so this is a good kind of a picture to draw, where you have a fixed coordinate system and a moving object, and then you have some velocities that are relative to the moving object. So it's kind of like you have a moving coordinate system here. This coordinate system with the plane has a floor that people move relatively to, and when you're inside the plane, you don't think of the plane moving, because you're completely enclosed. The floor doesn't look like it's moving. You don't feel like you're moving. But when you're outside the plane, you definitely have that feeling. So it's a good idea to draw a picture like this, like for the plane. Let's see if we had another. I think we had one other one that showed that. I'm trying to remember. Maybe not. Waiting. Yeah, so here's one other that shows that same idea where we have a plane moving forward rather rapidly, but the person inside the plane moving backward. Right? And so you take, for displacement, you would take the displacement of the plane minus the displacement of the person to get the overall displacement of the person. Right? And that's one of the ones we talked about. And for speed or velocity, it's the same thing. It's the same idea. You have an overall velocity of the plane moving forward, and this is actually still showing displacement, but in time, you take the delta x over delta t, and you take the velocity of the coordinate system that the person is in, and then you subtract off, or you actually add to it. It's not, you only subtract it because it's going backward. He was walking backwards. But you add the vectors. So you add the vector of the coordinate system that's moving forward to the vector of the person who is moving backwards to get their overall vector relative to this stationary coordinate system outside the plane. Right? So now let's go back to our problem and try to apply these ideas to our particular situation. So let's see here. This dumb thing is always in my way. All right.
Your screen is white, I don't know if you see anything.
Oh, you can't see anything right now?
Mhm.
Let's see if I can fix that. Oh, you're just seeing my whiteboard, that's why, huh?
Yeah.
Let's fix that.
You could probably have
Stop
that.
share. Okay. Is that better? My internet connection is unstable. Can you see my screen now?
Yeah.
Okay, good. So, that's the wrong class. Let's see what happened to my class. There it is. Okay, so now we go back to chapter 2, and we're looking at problem 5. And this is the problem we're dealing with, which is the cop car passing the sports car. The cop car is traveling at 35 meters per second. The sports car is traveling at 25 meters per second. What is the relative velocity of car B from car A's frame of reference? So car A is moving forward from this car. So we're going to consider this to be this is kind of like the airplane. Car B is the airplane because we're trying to do it from that point of view, right?
So copy is going to be a fixed point now.
And so car B is going to be considered a moving reference point. So it is moving. It's moving at 25 meters per second to the right. But we're going to pretend like car A is driving on top of car B. Like car B is really, really long and car A is maybe kind of like, it's almost like it's driving on top of it. What speed would it be moving relative to car B if it was driving on top of it? So this is kind of like the backwards problem from the airplane. From the airplane, the person was actually walking on the plane, and we were seeing his speed inside the plane, and we were seeing the plane speed. But in this problem, what we're seeing is we're seeing both the speed of the person inside the plane, which would be car A, and the plane, which would be car B, from the external reference point, because both of these speeds are from the external. So this is like seeing a plane that's going by at 25 miles or meters per second, and seeing a person on that plane going 35 meters per second. So how fast would the person on the plane be going relative to the plane? They would actually be going 10 meters per second faster than the plane was, right?
Okay, but what about the plane itself? Because that's what the first problem.
So the plane itself, if you're gonna look at how fast the plane is going relative to the person on the plane, if the person on the plane or the car that's going, this car is going 10 meters per second faster, then this one must be going 10 meters per second slower.
So negative 10.
So it's actually negative 10, I think.
Well, on my problem,
But it's
the
not.
number.
It's not,
So it's not showing you correctly. So let's
Yeah.
read it again, make sure we're answering it correctly. What's that?
Like I have different numbers, but like I put, it said that my cop car was traveling 36 meters a second and sports car 20 meters a second, and I put in negative 16.
Yeah, he put the negative sign too, like I did.
So you put the negative 16. Oh, but okay, so this is something that they've done in this that I should tell you, and I apologize for this. When they're telling you to give a relative velocity and they tell you to choose a direction, you don't want to put in the negative because the direction tells the negative. Because they actually haven't set up a coordinate system here telling us what positive and negative is, but they have given us an option for choosing direction. And that's kind of an important point. Now, if you put in the correct answer because you put a negative here and then you chose the direction to the left or whatever, and it marked you wrong, just send me an email. I'll fix that score. And I am sorry that can be extremely frustrating, but that is a very important point in physics. Is that if they give you an option for direction and they haven't given you an option for a coordinate system, you can't assume the coordinate system is one direction or another, because they haven't told you what they've assumed, right? This one does have a positive sign, so they have assumed a direction, but they've also given us the option for choosing a direction. So we have to go with that. And again, this is something when I give my feedback on these problems and I start to change these problems myself, I'm going to say, let's put in a coordinate system, or let's have them choose a coordinate system, and then and then we can go from there, because doing it both ways or one way or the other is confusing without a doubt. But it is one of those things that we have to kind of work with. So this one here, in this one, they're asking you to give the magnitude, and that's really what they should say. They should say, what is the magnitude of the relative velocity or the relative speed of car B from car A, and what is the direction? But that's just a way that they've written it. So in this case, in mine, it would be at 10 meters per second for the units, and then the direction would be what? Left or right, or none? It would be left, right? Because we assumed that positive was right, and it ended up being a negative one, because this one looks like it would be receding, or looks like it would be moving away from car A to the left, and so we would choose the left for that one. So mine would be 10, oops, let's see if it gives it to me. Now I can't get to my submit. I'm going to move you all over my screen. So if you get any of those wrong, just send me an email, either in my Open Math, or it's actually easiest to send it right from the question. If you just do this message instructor about a question and send it to me, it'll take me right to the question, and I can fix those points on there. And just say, I entered this with a negative sign, not realizing that the direction would choose that for me, and I got the right answer, and I can look and see and give you those points.
I just put, I put a period after the minutes. I think that's why it counted it wrong, because up here it wasn't wrong.
Yeah, so definitely write it as they wrote it, and just send me an email once again.
I'm just used to doing
And these things go away. I can promise you that this first week or two, maybe even 3 weeks, because it's summertime, it's going to be a little bit difficult to get used to the system. And then once we get used to it, I think that things will smooth out and it'll be easier for you. This is almost always the case in these classes where I use these electronic homework systems. But in the end, it usually takes a few weeks, but in the end, I think that you'll find that you'll learn quite a bit from having the immediate feedback and knowing that you got the answer wrong or right, and also learning how to enter it into a computer. Believe it or not, that actually has a huge value, is learning how to enter things into a computer, learning how to communicate with a computer. Most people's interactions with computers before they leave high school, most of it has to do with texting and tweeting and whatever else. It has almost nothing to do with actually communicating with a computer. And this is much more like how computers think. They think very exactly. They think very specifically, and they need to have kind of an understanding of what you're saying. So it's a very good experience for your future. I can tell you that much. Okay, did you have a question on 13 then as well?
Yes.
Yes.
I got confused because I thought the frame of references were the ones on the book. And you're supposed to go from the runner or go from them to the runner.
Okay, so the frame of reference is always the place that you're going to be considering to be not moving. So the frame of reference is like the airplane in the previous problem, where we have the man walking on the airplane, and he's walking at 0.4 meters per second relative to the airplane. So that's the frame of reference is always the thing that you're going to be in, and everything is moving around you. Okay. So if you're the runner, in this case I'm the runner, so I imagine that I'm the person running. What does everything else look like compared to me? Well, the hot air balloon looks like it's coming towards me, but since it's coming towards me relative to the ground at 3 miles per hour, and I'm moving towards it at 4 miles per hour, then it's like the hot air balloon is actually moving more quickly towards me because I'm moving quickly towards it, right? So you add those two to get a total of 7 miles per hour towards me. So it looks like it's coming towards me, which is to the right. So the hot air balloon would be 7 miles per hour to the right if I'm the runner. If I'm running with the river, and there's this raft on the river, then I'm running with the river, and the river is passing me because it's going a little bit faster than me. So it's going to the left at 2 miles per hour, right? All the other ones are, essentially the same. So you have the hitchhiker who is standing still, which of course would look like to me he's going backwards to the right at 4 miles per hour. Right? So any other questions about that one?
I just got confused with the runner because it's 0, like, but if I saw something that was still, I thought that, I don't know.
So you got confused with the runner hitchhiker one?
The runner himself.
Oh, with respect to himself?
I get that it's 0. I was just thinking like if you saw something still, but then I guess they were just like that thing's going backwards.
So you have to think of the runner as looking at himself. So he's running along and he looks down at his watch, for example. Does his watch look like it's moving faster than him or slower than him? His watch is part of him, so it's moving with him, and that's why he can read it, right? How hard is it to read a watch that's moving past you? It's very difficult. So the watch is stationary compared to you because it's part of you, and you have that 0 frame of reference velocity, which is nice. And these things are certainly difficult. The only reason that I have you do them, really, is to get you thinking in terms of, it's a good thought exercise more than anything. So it really kind of revs up the brains, fires up the synapses and gets you thinking about stuff. So.
On the 19th,
19?
the answer that I put -2 for my answer, but the actual answer they wanted was -2.0.
So you just rounded and it didn't launch it around?
Yeah.
Okay. You can
Which
go. Sorry.
Because it's not that big.
Yeah. Just try to round to a couple of decimal places when you can. That's best, and you can go ahead and just send me a message about that.
As for number, well, I have two questions. 8.
Number 8.
Yes. Your graph.
Yep.
Oh, no. So, wait. Velocity. It's moving back.
So a negative velocity means that it is moving backwards, right? Is that what you're
Yeah.
asking? And the only places that we have a negative velocity are between 0 and 10 seconds and 70 and 80 seconds.
Okay. Look at number.
Number 6 right here?
Yeah.
Sure.
It asks where is the.
Okay, so in this case, remember we're looking at a position time graph. So this is the position of the object. So at time equals 0, we're at 8 meters from 0. And then we stay at 8 meters for 2 seconds, and then we move to 9 meters. So if you move from 8 to 9 meters, then you're going to be moving forward to the right, right, for that positive direction. And then we stay at 9 meters for a second, and then we go from 9 meters down to 0 meters. Now that is moving backwards. So in this case, when a position graph, a positive slope is a positive velocity, or moving forward. A negative slope is a negative velocity. So we have one there, we have one here, and that's it, right?
Okay, so position time graph equals the velocity.
That's correct. So the two different graphs you have to treat differently because of what they're actually tracking.
You didn't pay attention.
Yeah, that's one of probably the number one thing to do when you look at a graph. The first thing to do is always look at the axes. This is a position time. And that's the reason that I showed you that graph at the end of class yesterday, where we had a graph that was not a position time or a velocity time. It was actually a velocity position graph, which would be very confusing if you didn't read the axes. And even when you read the axes, those position velocity graphs can be a little bit confusing. So it's always important to read your axes first. This one's position and time.
Thank you.
Yep.
I think I just have one. Sorry.
Go ahead.
Um,
Number 4. Average velocity for the man on the diagram below if it took him 34.7 seconds to complete the path shown. So remember that velocity has a definite definition, right? If we go to the book and look up the definition for velocity, it will tell us that the velocity is delta x over delta t, where delta x is the final position minus the initial position, and delta t is the final time minus the initial time. So let's go to our little whiteboard. Oops, that's not what I wanted to do. Let's go to our whiteboard and write this down. So velocity average is defined as delta x over delta t and delta x is final position minus initial position, and the time is just going to be time, the time that it takes. The time that they've given us was 3 point something seconds, 3 point whatever, I don't know what it was, seconds. And the positions now are what we need to deal with. Well, this guy starts off in his position here, and he goes somewhere, and then he turns around and he comes back. So what's his initial position? Let's say that this is, let's call this x equals 0. We'll call this up here x equals Chicago. Doesn't really matter what it's called, right? It's not going to really matter what this x is up here. Why not? Where does he start? At x equals what? He starts at x equals 0. That's the initial. Where does he end up? At x equals 0. So he ends and begins in the same spot. So what does this equation tell us? Average velocity is 0. Because 0 over 3 is still 0, right? And 0 minus 0 is 0. And 0 times anything is 0, and 0 divided by anything is 0, so it's always 0. That's a trick question. Remember that I warned you I love trick questions, and all physicists do. But the reason for this is to recognize that velocity is a point-to-point distance. So it's a ending point, beginning point distance. And if you end at the same place that you begin, then your average velocity does end up being 0. Whereas if we were talking about speed, we would have to take the distance that he traveled divided by the time, which is a very different thing, right?
My question about that,
But go ahead.
I didn't run calculations, but I don't know how I do direction.
Okay, so yeah,
The goes forward
so
27.
let's see. I'm going to enter this in really quick, make sure it works. The average velocity is a scalar, turns out. See if I got it right. Nope, I didn't get that right. Let's see here. Did I have the same as you did? Oh, I didn't have the same as you did. I apologize. Were your distances different?
Yeah.
Oh, I didn't recognize that they were different. So they are different. You have to plug those numbers in.
Yeah, that's getting
Okay.
the answer.
So yeah, those distances are different, and then we get what do we get? We get 31.1.5,
5.2.
4.1. I get 5.4 for that ish. So if I get 5.4 and submit that, that should be correct. That's not right.
It's 27. It's 10. 5.30.
Oh.
So 0.5.
That is, I don't get it. Let's see what's going on here. Am I doing my math wrong? I don't think so. 5.9. Uh, 5.6, right? Should be right. Let's do the math. Let's write it out. Okay, so let's actually do this really quick. Where's my thing here? So this math is different because I was reading it wrong. And so what is our final position? Our final...
27.
I have to do mine because I have to check it, right? So I can't remember.
Oh,
25.9, 31 point. So we go from 0 to 25.9, and then we go 31.5 back. So our total change. Oh, I didn't divide by the right. That's what I did. I didn't divide it. Okay. So it is 5.6. I got that right, but this is the 5.6. I forgot that it was 3 seconds. So let's do the 3 seconds. What is the actual time? It's 34.7 seconds. So that's good to know. So what is our average velocity if we take 5.6 divided by 34.7? Where's my calculator? I couldn't hear you, sorry. 5.6 divided by 34.7. Was it 34.7? 34.7 equals, so that's 0.1. Is that what you were saying, 0.161? I couldn't hear you very well. For some reason, your audio is not coming through. 0.161. Submit that. Okay, so now it looks like we got it right. Because what we did is we took the difference between those two distances, and then we were able to get the correct overall displacement, which is the delta x. So that gave us this displacement divided by the 34.7 seconds, and we got 0.161. So did you have that correct?
Yeah.
And you have your meters per second correct. And now we're looking at what the direction is. Now in this case, it kind of depends on what the book tells us. I'm thinking, since it's telling me that it's not correct when I chose no direction, it's a scalar. Some books choose to define average velocity as a scalar, some choose to not define it as a scalar. It really just depends, it really depends on the book. When we get into average velocity in multiple dimensions, it will be considered a scalar. For now, it looks like they're not considering a scalar, so we have to give it a direction, which means we're going from our original position, which is at 0, to a position that is lower than it because we came back further than we went out, right? So we're coming back to a position that is further down from our original position, so we're going to have to choose this further down one and submit that. And that, of course, gave us the correct answer because that was that. So, and I'm assuming that you chose one of the zeros. Is that what you did? No, one of the no directions, rather?
No,
You chose.
mine was up.
You chose yours as up and as. What were your numbers again?
0.5, oh, sorry, 27.7.
27.7 up and how many?
Well, 10 down.
So you were going more up than down.
Yeah.
Okay.
So because ended up further up with down by the direction.
Yeah, and that's because you ended up further up than you were down. Because remember, the definition, it has to do with displacement. We go back to our definition. Come on now. Where'd my whiteboard go? Can't find my whiteboard. It's lost. Oh, there it is. So remember the definition, and this is another example of believing the math, right? The definition says it's displacement over time. And so the displacement has to do with where you end up compared to where you start, not your path. The path that you take there doesn't matter. All it cares about is where you end up compared to where you start. And so if you end up 5.6 meters below where you started, then your velocity is going to be pointing from where you started to below where you started. If it ends up 3 meters above where you started, or 12 meters above where you started, or whatever it ends up being above, then your velocity is going to end up pointing from where you are, where you started to where you ended, which is above. And that's what it has to do with. And that's the most important thing to remember about these vectors, is that they have a definition, and they start from the starting point and go to the ending point. They don't care about the path that you take to get there. Okay? And it is certainly confusing because this is a new idea, especially if you've not taken a physics class before. It's a completely new idea. And frankly, most people who take this class have not taken a physics class before, so that's just normal. So, takes some getting used to, for sure.
Those are all mine.
Okay. You guys have any other questions before we? Yes. Go ahead.
Like, if she,
Yeah, she's done with her questions.
okay, I have some questions, so I'm gonna probably stay here longer.
That's good. We can stay here as long as you want. If any of you want to leave at any point on a day like this where we're just reviewing homework, you're welcome to. Some days we will try to move ahead to the next chapter when we're done with homework, but today we won't be doing that since I'll be gone for the next week, so for the next rest of the week. But today you can just ask your questions.
So tomorrow, we don't have
Yeah, tomorrow we won't have class. I'll be gone to California.
Are you gonna record a lesson, or we just won't have it?
Since we met today, we won't record the lesson and we just won't have a lab this week.
Okay.
So since we've met twice already this week, we've satisfied our requirement. We've got all our time in, and we'll start chapter 3 next Monday.
Okay. If she's there, she can log off, but then I have a question.
Go ahead, ask your question. I think
It's,
we're good.
I realized what I did wrong on the number parts. Do you remember what number it is?
13.
Yeah, 13.
Yep.
I don't know what I did wrong here.
Okay, so
Because
the
it's from the frame of
hitchhiker.
reference from the hitchhiker, and the runner's moving 4 miles
So
per
the-
hour to the left.
Yeah. So what we're trying to do here is we're trying to say if the runner is our runner is our frame of reference, what does the hitchhiker look like from the runner's point of view? Does he look like he's moving to the left or to the right?
Oh, I thought it was saying that this is your frame of reference.
No, your frame of reference are the blue ones down here, which is I think why
Yeah.
they made them
Dang
blue.
it. Okay.
Sorry, I think that's why they highlighted them in blue so that you could see what your.
I know,
frame of
I just
reference
always
was.
thought that I was the one going across the top. Dang it.
Sorry.
I bombed it.
I will issue them tomorrow.
Now, there's another thing that I've noticed while we were looking through this really quick, and before we get on to another question, I have I've set up the settings for this homework assignment so that problems that have like 14 parts are worth 14 points, which really can hurt you in the homework, which I don't like, because then you have a problem that's like worth half the assignment. So I didn't mean to do that. I'm still like I said, we're still kind of setting this up, and I can fix that. Let me just try to fix that really quick so that I don't forget. I think I've set it up correctly in the other homework assignments, but let's fix this one really quick. So we don't want them to be worth 14 points. Let's see, that's two. What chapter is this? That's chapter 1. I don't want to be chapter 1. I want to be chapter 2. Chapter 2. Okay. Here we go. I should be able to change that. So let's. Ah, yes. Yeah, let's. Assessment
There we
settings.
go.
Change settings here. Points. 1. That's better. Change points. 1.
So it's the points for all problems on that.
Yes. So yeah, and it's not it's not perfect because some problems are just harder than others, but I don't want you to feel like a hard problem that you miss some parts of and you get some parts of is going to kill your homework assignments. It's just not fun at all. What the most important thing about the homework is to give you experience, not to give you headaches. So we'll try to make it as headache-free as possible, even though that's impossible in physics to be headache-free.
This,
Yes.
when you, it didn't change our number.
What's that? It will change it later. Is that what you're asking? It didn't change it in your homework?
No, it doesn't have a 57.4 after the
Okay.
Pick up a 13, it says 13.9.
Oh.
It's a 13.8 on 1 on 1.
I think that I can also regrade the assignments. I think that just has to wait until I'm done changing all these things. So I'll regrade the assignment. And if it doesn't regrade automatically, I'll just regrade it by hand. So that's not a problem. I'll fix it. Unless you guys don't, maybe you guys want 59 points out of 14. Wouldn't that be nice?
Yeah. Because right now it says my grade's 31.8 out of 20. I can look for that.
Let's see
I still
here.
haven't answered that.
Yeah, I think that I can go back and regrade the questions.
And
Let's see.
on that 14 part one that I had the frame of reference filter out in my mind, is that one that I can email you on, or is that one where it's kind of like my error? So.
Oh no, it's fine. You can go ahead and you can send me an email. I understand. Okay. Let's see. Average points. Yeah. So the average points, the average percentage on number 13 is 1,300%. Good job, you guys. Yeah, I will go back and get that regraded here before too long. So what's your next question here? 21?
I just don't know what equation to use. I know that I know speed and time. Like there's this equation B would not the speed, but I don't know.
Well,
Wait, is this turning also zero?
so
So I don't know zero,
this is one of those situations where you need to write down what you know and try to figure out something, some equation to use, right? So what we know is the initial velocity. What's the initial velocity? No, what's the initial velocity? So what do we do when we start a problem like this? We draw a picture, right? So we draw a picture. So we've got a person throwing a ball upward with a velocity of some velocity, 46 meters per second or something like that, right? Some velocity initial that has a value, some number, right? What's the acceleration on the ball? Is there an acceleration on the ball? If you throw a ball upward in the air on the earth, does something try to pull it down?
There's the acceleration by gravity.
Right? We have gravity. Negative 9.8, or if you use the equations that already have the negative in them, you don't have to use the negative on it, but meters per second squared, right? So we know an initial velocity, we know an acceleration, and what else do we know? What else do they give us in the problem? Times. They want to know what it is after 1 second, what it is after 2 seconds, what it is after 3 seconds. So now you know initial velocity, you know acceleration, and you know time, right? What do they want to figure out? They want you to figure out the final velocities at those times. So now you need to find an equation that can do that. I'm going to excuse myself for just a minute, and I'll be right back. Okay, sorry for that delay.
Eventually, switch and say they're wrong.
So tell me what you used. What equation did you use to do this?
V equals V naught plus easy.
So v equals v naught plus acceleration times time. And what did you put in for your acceleration? Negative 9.8. And you put in 1 second for your time, right? And what did you get?
My starting velocity was 60, and for the first second I got
Let's see here. Let me do this really quick. 9.8 plus 6.2. Okay, so after 1 second, did you get that one right?
yeah, I got it.
You got them all right? Okay. And so what was your question then? Did you have a question?
Yeah, I was thinking of this 60 has acceleration instead of starting velocity for some reason. So I was getting confused on what equation to use.
Okay. So you're just clarifying. I mean, I'm still
Well, I
not.
missed it all,
Okay. So you're good to go. Sorry.
Mr. David,
Yes.
on number 4,
Okay.
mine is a little weird. Like, I saw some of the other people's equivalent of number 4. I'm like, okay, never mind.
Is that like yours?
Well, mine's beside with different numbers, but it's asking, instead of clicking 9.5 seconds to complete the path show.
Okay.
So like 9.5 seconds to complete both paths.
Yeah.
Okay.
Totally.
So I did that. Distance divided by time, which means I wasn't sure how many decimal points you were supposed to figure out.
Oh, take it a couple of the. Remember that it's not just distance; it's displacement. So final point minus initial point, right? So the first one we did was kind of the trickier one, the trickiest one, much trickier than this one. This one, obviously, you're going to be 23.7 plus 11.5 meters away from where you started. The other one, you had to take a difference. This one you can just add. If you have one where you have to take a difference, it's just a little trickier. Gotta make sure that you get everything correct. Now, is anyone going to think they're going to need more than tomorrow night at 11 p.m. to finish this assignment? Because if you do, if you feel like you're going to need a little more time, just send me an email. I can give you a little more time on it. It's no problem. What's that? 22. Oh, yes.
I just take it out to 2 or 3 different decimal places.
I did 3.
2 or 3 is fine. Yeah, whatever.
Just based on that.
That shouldn't. So yeah, in this one, you're actually going to be doing some drawing on this chart here. And so if I'm going to go from position -5, position of my y-axis, so I go down here to -5, and I'm going to go from time equals 1, I'm at -5, and sorry, time equals 0, I'm at -5, time equals 1, I'm at -4, then I just go from here to here, right? And then from 1 to 2, I go from -4 to -3. So I go from, oops, this thing's in my way. Then I go from, good night. And they're probably going to want you to do a continuous line, so I'm going to Whoa, what did I just do? Oh, that's cool. I didn't know I could do that. This is the first time I've used this chart. So if you just click on -4 and let go, then you can drag it. You don't have, I mean, you don't even have to drag it. You don't have to keep your finger on the button or anything. So if it starts at -4, goes to -3, and then it stays at -3, right? No, I can't. Too many things on my screen here. Okay, there we go. So it goes. That's wrong again. We're going from -5, and we're going to -4, and then to -3. And if I click there and let go again, it lets me draw another line without breaking the line. So at 2 seconds to 3 seconds, I go from -3 to -3, so I stay on a nice flat line there. And then to all the way out to 4 seconds, I stay at -3, so I can go out to there. And then at from 4 to 5 seconds, I go down to I go to 2.7, so it's about right there-ish. And then from 5 to 6, I go up to 2, right? And then from 6 to 7, I go to -0.7, so I go to about right here. And from 7 to 8, I go to 1, so I go all the way up to +1. And then from 8 to 9, I go to 3.2 to 3.2. And then from 9 to 10, I go up to 6. And then I'm done.
So as long as we have been close on those decimal places, it won't matter.
Let's see. I don't know if this one is graded by hand. Yeah, so I was pretty close, and I got it right. So it does grade it automatically. Some things in Mildly Math are designed to be graded by hand, so I have to go in and look at them and determine whether or not they're correct. But this one apparently can do it. So.
Mr. Bailey, I have a question on
Number 10. What's your question on number 10?
okay, so the distance is pretty easy to figure out. It's just the average speed. It says that like he travels a little bit, he rests, then he travels again.
Yep.
So do you count the time that he is resting anyway? That's part of the total time in figuring out the average speed.
Yes. So they want to know his average speed for this entire time interval, including the 4 minutes. So the only other way to do that is to take an actual average, which we haven't talked about doing. A time average is not something we do in this class. So what we do is we take the entire time and the entire displacement to get that. Well, the average speed takes the average distance, is the distance, not displacement, right? So you get the distance traveled divided by the time that it took to do it, total time including rest. And you're good to go. Anything else? Okay, so let's consider these first 2 weeks kind of our physics honeymoon. This is where it's nice and easy. Remember, at the beginning of most people's presidencies, for example, they give them a honeymoon where they don't pick on them too much. I'm not sure this current president is getting one of those, but
Nope.
usually.
Close.
I think it's fine with him though, because I don't think he cares. I don't think he cares about anything personally, but with previous presidents for my entire lifetime, they always gave him a nice press holiday or a press honeymoon where they didn't ask him any really tough questions, and they gave him a gave them a lot of passes on stupid things that they did and said, which all presidents always do. And we're going to consider this our physics honeymoon, where we took it kind of easy and slow so that we could get things started. We could start to understand how to use MyOpenMath, and we'll still be learning how to use MyOpenMath, and we'll certainly be still learning physics. But we are going to move a little bit faster starting next week. We're going to move into we're actually going to move into two-dimensional kinematics, which is also challenging, so we won't move too fast through it. And then we'll move into dynamics, which is also new to us, so we won't move too fast through it. But we're going to try to move a little bit faster. Actually, day by day, we're going to try to move a little bit faster. I want you to be aware of this because as I'm moving faster through the material, if you have any questions, do not hesitate to stop me and slow me down. I'm going to assume that the stuff we've learned so far is sticking and that you're understanding it, because I'm looking at your homework and I'm thinking, oh, they've got it, they're figuring things out. But if you still have questions, don't let me just blow through something that you don't understand. I will stop, I will backtrack, I will slow it down if I need to. You just have to tell me. Because if you don't tell me, my brain is going to be thinking, we got to get forward, we got to get done with this chapter because we got the next chapter, and we got the next chapter. And we got 16 of these chapters we got to burn through. And we only have 12 weeks to do it. So we got to get through. Particularly towards the end of the class, we will move quite a bit quicker because we will usually be trying to do a couple of chapters a week towards the end of the class so we can hit all those 16 chapters in those 12 weeks. But once again, don't let me blow through something that you're not understanding. Don't get frustrated and don't get confused because I'm moving a little bit more quickly every time we meet. It won't be stark. It won't be right away. We're not going to jump deep into the pool. On Monday. We're just going to gradually get faster and faster and faster, assuming that you're learning these things and you can make those leaps. But it's no bad reflection on you if you ask me to stop or slow down or explain something. I'm more than willing to do it. You just have to tell me. Okay? Particularly distance learning students struggle with this sometimes, so don't be shy. Speak up. Okay? You're so kind of disconnected from the class in so many ways. It's hard to keep you involved, but we want you to be involved. So don't hesitate. Do we have any other questions? Anything else you want to do? 23? Doesn't tell you which one's wrong? Oh, it should tell you though. Let me see your thing. I think if I open my version of this in your homework, I think I can see which one's wrong. So let me try that really quick. Chapter 2. Number, which one is it? 23? Huh. It's not telling, it's grading it all as one for me as well. Let's see. Well, let's take a look at it. So, actually, I can see which one you got wrong. So well, if I tell you which one you got wrong, you'll know what to do. That's part of the problem, right? If I tell you which one you got wrong, you only missed one. So, well, you missed two, but they're interchanged, right? So let's just go through them one by one and take a look at what they need to be. Let me get back out of here so I can go to my homework. Okay. So, 23 is this matching time velocity graph thing right? So in the first one, we have something that is, we have 0 that's up here. This is our 0 point, right? And this is a velocity graph, so is this velocity positive or negative? If this is graphing velocity and the graph is below 0, that's negative, right? So this is a negative velocity. So you know what you did wrong? So this one is a negative velocity. However, it is moving towards a positive velocity. So it's becoming less and less negative. It's obviously accelerating in a positive direction. But it hasn't stopped yet because it hasn't reached 0. So that A1 is this, is it, which one is that one? Moving in the negative direction and slowing down, is that one? Moving with the, moving, yeah. So, do you have any other questions about that, Bo? Easy to get these wrong because it's easy to forget what you're looking at when you're looking at a graph. And that's why it's so important to learn how to do them, to work with them. They can teach you a lot and they can give you a lot of information, but only if you learning to read them properly. So, anything else you guys want to do?
I'm working with a couple right now.
Okay. Well, unless you guys have any other questions, we can stop for today, and I can hang around if you have any other questions. I can hang around for another hour or so. I've got some things I need to do here on campus anyway.
I have a question that's about that. So another one second.
Okay, go ahead.
So I can hear myself echo. So if I stutter, it's because I can hear myself.
That's all right. I never did send you the software, did I?
Yeah, that's what I was going to say.
Okay.
So
Sorry about
I
that.
downloaded Longer Light,
Yes.
and so I've been trying to do this, but the only one that I wasn't able to, well, I quit because I was frustrated.
Yeah, I can
But I
understand.
couldn't set it to go for 15 seconds.
Okay, so let me bring up Logger Light really quick and see. So Logger Light
I
is
just did the 5-second ones.
Logger Light is a program that I think you can do the whole thing with. I
have my boyfriend's sister run for me.
Let's see here. One of the problems with sending the lab to a distance learning student is the fact that my license for Logger Pro is a site license. Let me see if I can find that. I can't find it for some reason. Let's go ahead and just download it again.
With the acceleration.
I'm pretty computer savvy, but I couldn't find it.
And again, there is a bit of a learning curve when it comes to doing these labs with the computer and everything else, and that will take some time to overcome. It's the same here on this end. It takes some time for everyone to learn it. And just so you know, even when my students are here, I do require them to do the labs mostly on their own. So it's the frustration is kind of normal, but it's also part of the learning process. Learning to use a computer to do science is part of this lab. That's one of the things we want you to learn, is to take data with a computer, to use a computer to analyze things. So that, unfortunately, is part of the life of a physics student. And so don't feel like you're being singled out or it's or anything else. It's just kind of the way we run physics labs. It's normal, actually, across the world. Physics labs are done very hands-off by the teacher. It's very common because we want students to learn from each other and from the actual experience. So let's open this up really quick and show you some of the things that you can do with it and how to do them.
For typing in this equation, how do I show that, like, how do I show that it's 0 in the subspace?
Put a v_0. And also, if you hit the little button to the right,
I
or
tried that and it didn't do anything. The preview button, it didn't do
well, not the preview button. Hold on a second. Let me talk to her first, and then I'll get back to you in a second. So okay, sorry. So here is logger light. Why is it not doing anything? Because I don't have anything connected. I've got too many bars up here. I need to move these bars around. Here we go. Okay, so if we come up here to experiment, and you go to data collection.
I can't see it.
Let's see.
I'm on whiteboard.
Whiteboard. I keep going back and forth and not going back. Let's go back. Desktop. Here we go. So here it is. I got to move this toolbar. How do I get this toolbar? Here we go. Okay, so if you go up here to experiment and go down to data collection, then you can change your time here to different times. And once again, I apologize for not sending you that and showing you this, but you can change the time. You can also change it to continuous, so it'll take data until you stop it. So you can do that as well. You can also do it, well, you don't need to do that. You won't need to use that. You can also change the samples that you take per second. So if your graphs are looking really jittery, looking really not very smooth, then you can increase this. There's different devices have a maximum sample rate that is different. So, but I think that the one that I sent you, the motion detector I sent you, I think will do up to 20 a second or something like that, or maybe more. So you can just
Here.
yeah, so you can set it up to 100, and if it can't do 100, it'll just set it to the highest thing, so that you can have a nice smooth curve, or as smooth as it gets. You know, you may have noticed that it's not as smooth as you might have imagined, but that's real life for you, right? So that's what one of the things you want to know. Another thing that you want to know about this. Let me check something really quick. I don't think that. Yeah, so if you're in the lab, let's see. This is physical science. No. Okay, so in the lab they tell you to open a certain file, and this particular logger light does not have those files loaded into it. So you won't be able to open those files that they tell you to open. What you want to do instead is open up Windows with the proper graph. So when you plug in, let me plug in something really quick and I'll show you.
I only did the first 2 pages, so.
Sorry, I gotta get all this hardware plugged into my computer. It's not usually plugged into this computer, so. So right now I'm going to plug in a motion detector, just like you have. A little bit different than yours, but it will bring up the same stuff on the screen. So once I plug in a motion detector, if I can plug in my motion detector, why can't I plug in my motion detector? Dang it. It's going to drive me crazy. Now I've got the right one. So this is the same exact motion detector you have, so it'll look just like this. You plug it in, and it brings up your chart here, your graph. And this should be what you saw. And what you can do is you can click on the graph, and it gives you the little dots at the corners, and you can change the size of your graph, and you can also move it around. So you can move this one up, and then you can actually add another graph. A couple of different ways to do this. You can just right click over here, and you can add, let's see, no, I want to add a page. I want to go up here and let's see. Oh, insert. Yeah, insert a graph. So you go to insert graph, and it gives you another graph. Now, in this case, it gave you an acceleration graph, and in this particular lab, you won't need an acceleration graph, but we can change the graph. If we go over here to the y-axis, we can choose what we want to put on there. So we can go over to column options, and we can choose the velocity, which is one that you will need. So you're going to use velocity, you're going to be done here, and then, whoops, let's go to graph options and change it there. Axis options. So on my axis, instead of it being acceleration, I'm going to choose velocity, and then I'll go ahead and change that. So now it's a velocity graph, and then I can change the size of it and everything else. Okay? Now when you go up to change the time, if I go up to experiment and I change my time, go under data collection, and I change to say 15 seconds, and then I'm done, it will usually change the graph down here to 15 seconds. But if it doesn't, you can always click on the biggest part of the graph, and you can change that. So you can change that to 1, and you can use that to zoom in on the graph as well. You can also go to negative. If I go down here to 0 and I type in -2 here, then I can change the graph to go from 2 to -2. Okay? Another useful thing, of course, is the actual numbers that it records over here. So once you've collected some data, right, and then you come over here, you can actually look up actual numbers in your chart to use for calculations or whatever else. Anything else that I can think of? I can't think of anything else at the moment. But
Is there anything I can email you with?
yeah, you're more than welcome to email me. There's,
So that I know this.
oh, here's another thing here's one more thing I want to show you really quick. If you go to this examine tool, and then you come along your graph, it'll actually show you points on the graph in this little box right here. So it actually shows you point by point what your data is. What's that?
It doesn't go down.
Yeah, it also it crawls up and down on the graph and gives you the point on those at those places. So that can be useful as well. So now tell me what were you going to say?
So when I'm done with this, do you want me to take pictures of it?
That's fine if that's easiest for you. You could also you could send it over to the extension center and they could scan it to me, or you can send it directly to me. Either way, pictures are fine with me. Whatever works for you. Pictures are fine as long as I can read them.
And scan it too.
Yeah. Any old way is fine as long as I can see it and read it and get a good idea of how well you did on it. So,
Alright.
anything else?
Well, like I said, I only got to the third page, so.
That's fine. Yeah, just kind of try to work through it and get as much done as you can. So. Yep.
I also messed up.
Number 23.
Hold on just a second, really quick.
I messed up pretty badly.
Oh, no worries.
So I just made new grass.
No worries. No worries.
Okay.
Sorry, go ahead.
Number 23.
Back to number 23. Okay, we're going to go back to the homework. Number 23. Let's see. 23. Is this 23? It's 23, yes. Okay.
And so they got 2 wrong. And I overheard them, he said he couldn't tell which ones were wrong, so he just flipped them around.
Yeah, if you got 2 of them wrong, I can't really tell you which ones you got wrong, but we can talk about them, right?
Yeah.
So what's going on here in the first one? We have a negative velocity, but so let's say that negative is to the left and positive is to the right, just for argument's sake. So this one is moving to the left at some clip, and then but it's slowing down. It's not moving to the left as much as we go in time. So it's slowing down. It never stops, but it's slowing down, right? This one right here, what's it doing? Where is it starting at velocity?
It starts kind of at your origin and it's just.
So what does that mean? It's movement.
Positive.
It's got a positive movement, but what does it start?
Starts 0.
Starts at rest, right? So it's starting at rest, and then it's going in a positive direction with a positive velocity. Is the velocity increasing or decreasing? It's increasing, right? What is C doing?
C, it's moving with a constant negative velocity.
Constant negative velocity, constantly to the left, doesn't change at all. How about D?
D had positive velocity and it starts slowing down.
So a constant positive velocity, and then it slows down, but it never stops, right? What's E?
E is moving.
Just sitting there, right? F?
F wasn't moving and then it started speeding up in the negative direction.
That's right. So start speeding up in negative. What's G?
Constant negative velocity, then it slowed down, then it wasn't moving.
Then it stops.
Started speeding up in the positive direction.
That's correct. Right. And H?
Constant positive velocity.
And I?
It's slowing down.
It's a positive velocity that is slowing down, never stops, but it's slowing down, right? And J?
Had constant negative velocity and then started slowing down.
That's good.
I don't know. I think I might have got A and I flipped around. Can you scroll up for a minute? So A is moving in the positive direction and slowing down.
Just the opposite, right? A is a negative velocity and slowing down. I is a positive velocity slowing down.
Okay, I think that's what I got wrong. I flipped A and I around.
That seems to be a
Why did I
common
get
one.
wrong on this?
Yeah.
My computer died and it can't charge.
Equations to solve for variable you desire, or rearrange the equations. So V equals V naught over, is that a 0 or an O?
It's 0. I typed it as 0.
Okay. So we're solving for A. So we subtract V naught, then we divide by T.
Put parentheses and everything.
Looks correct to me.
I looked at the
Let me
arrow
just-
thing that showed what it was supposed to look like in an actual, like, and it showed how it was supposed
Let me, what number is this here?
16.
16, okay, let's take a look at it. So in this one, if you click on the, if you click on this more, did you do that?
I clicked on the yellow arrow
And
thing
then
and
the
it
yellow
showed me.
arrow.
Yeah, it showed me.
Okay, so in this case, this, you can use this as your, is not your subscript. So I would go ahead and use that. But let's try it really quick. We have A equals
When I pulled it up in there, it showed it as a
V
script.
minus V 0, and then we put parentheses, whoops, get out of there. Put parentheses, dang it. Parentheses first. V minus V, and then we do a subscript with a 0. And then we'll do these, whoops, we'll just do it divided by T, and that's what you had, right? Let's see if it works for me. V minus V naught T, submit. So it just, I think what, and let's see here what they've done. They've done a
That's
double
two
parentheses, and I don't know
That
why.
must be why it's wrong. That's the
The
only
only
thing
thing,
that's different.
the only thing, yeah.
That's how it's different.
Let me try it another way here. Let's try V minus V underscore 0 divided by T with parentheses. Let me try it this way. This should work. I don't know why it wouldn't. It's still working for me. My guess is that you put in an O instead of a 0. That's a very common mistake, but it's not always possible to tell.
I typed in 0.
Well, let's try it. Let's try it again. V minus V 0. That looks different, but it may not be different. Wait, you have capital V's. Are those capital V's? No. No. V minus V underscore 0. Oops. Parentheses divided by, where's divided
Oh, it's, you have to go to a bunch of different things to find it on there.
by? That may be the problem
Well,
because
because I did it on the laptop before, but then
Yeah. that may be the problem, that you may just be not getting the correct symbol here. Oh, here, let's try this one. Numbers, how do you get to it? Yeah, it just, the phone may not be entering the proper symbol.
Well, what,
That's
well,
possible.
the one that I typed it in on the laptop when it said it was wrong.
Well, yeah, the syntax works here. I don't know how phones, I don't know how they interpret different symbols. There may be a discrepancy there that I'm not aware of. So that's possible. But it may be a mistake the phone made.
But I got it wrong on the laptop.
So when you typed it in this way, the only thing I can think of, the most common mistake is people will put a capital O instead of a 0, and that's easy to do because they're right next to each other as well. So that's one possibility.
I did it on the laptop and then.
Let me check. Let me check here. I can actually see what you did here in the homework. We'll see if there's a clue there that tells us what happened.
Maybe just the rest of it real quick, Mr. Daly.
Okay. Which number was it? 13? 16. 16. Oops. We're in the monkey problems. Okay. So V minus V preview. Says the syntax is okay. Why doesn't it like it? I don't know. I don't know. It's kind of goofy. Let's just give you credit. How's that work for you? So now, yeah. Okay.
I don't know what I did wrong on 15.
15?
Put 700 as the distance. Everything else was right. I don't think I used a formula, which is
You
probably
did
why it's
that.
wrong. I don't know what formula.
Oh, yeah, this is, so the car accelerates. So that's just something that you left out of the formula. There is because you're starting from 0 to a final velocity, you actually used a formula that calculates it for a constant velocity, but it's not a constant velocity. Remember, it's accelerating, so you have to use a different formula. You have to use a formula that has the initial velocity and the acceleration and the time.
This on Thursday.
Yeah. That's a common mistake made.
So with this equation, x equals x naught plus.
Yeah, that would be a good one. Any other questions? You good to go, Cassidy? Oh. Sorry.
Would x not be 0?
Can you hear now?
Yes.
Sorry.
That's okay.
I accidentally muted the sound there for you.
I just want to ask, when I was doing graphs, right?
Yep.
The first one I did, it gave me 0 to 2 meters on the side, going at 0.5 degrees.
Okay.
But then when I tried to change something, it switched to 0.5 to 2,
Yeah.
and I couldn't change that. So I have one graph that goes from 0 to 2, the others go from 5 to 2.
Yeah. So that's is that in your y-axis here?
Yeah.
Yeah. So whenever that happens, just go ahead and click on it and type it in.
Okay.
So you can just type. So if it's going from 0.5 to 2, just type in a 0 again, hit enter, and it'll fix it again for you.
Okay, so my first ones are different, but that's
not a problem. Not a problem.
I'll just stay consistent from now on.
Yeah.
Next question, when my starting distance
Oh, I know.
and starting velocity is
Okay.
0,
Are you going to sign off then?
Yeah, I think so.
Okay. We'll see you later then.
Have a good time in Cali.
Thank you.
Bye.
Have a good week. Okay, so what's your question?
would my starting distance and velocity both be 0?
Wait, is this the same problem? Was that 13? 15? Keep saying 13. Distance traveled 0, you say?
The starting
Oh, the starting position. Yeah, the starting position is 0, yes.
and the starting velocity
Starting velocity is also 0.
Mr. Bailey,
Yes.
the only problem I have left is number 12, because I have a question about, it's one where the cyclist has a tailwind.
Cyclist, looks like velocity rides with a tailwind, okay?
So, when they're riding with the tailwind, do they take on the velocity of the split the difference?
In this class, we're going to assume that they take on the velocity of the tail.
Okay, so this velocity would be 11 meters per second. Well, for mine, it'd be the velocity of the tailwind in the direction it's already traveling. Since they're both traveling in the same direction. Okay.
Now that's not exactly true in real life. I don't like this question as much as I like the river question, because in a river, carrying a boat, that's much more the case, because the friction between the water and the boat is much higher than it is between air and cyclist. But we're going to assume that this is the case.
It said I got it wrong, but a lot. Because it says that the cyclist is doing 9 meters a second and the tailwind is 11 meters a second.
South breeze, 10 meters per second. Let me just check here. Okay, so what did you put in for your answer?
I just put in for the velocity, I put it in 11 because it had the unit in direction.
So your question says the cyclist has a speed of what?
Cyclists have a speed of 9 meters a second and the tailwind is 11 meters a second. Should I try to put in 20?
So 9 and 11? Yeah, it should be 20.
Okay.
We're just
Sorry, I
talking
thought
about.
it was just Yep, now it's right. So if I don't have any more questions,
Yeah, if you don't have any more questions, we can be done. Are you done, Leslie? All good? Okay, yeah, we're done. We'll stop the recording and post that for anybody.